Welcome to Emerging Technology Horizons. I'm Mark Lewis, the Executive Director of NDIA's Emerging Technologies Institute. And on today's episode, we have the Honorable Alan Shaffer. Al is extremely well known within the DoD S&T community. He's held numerous positions in the Pentagon, including most recently Deputy Undersecretary of Defense for Acquisition and Sustainment, the A&S office, a position he held starting in January 2019 until the end of the previous administration. Al was also, from 2015 to 2018, ran the NATO Collaboration Support Office in France, and so oversaw science and technology for NATO. Before that, spent 8 years as the Principal Deputy Assistant Secretary of Defense for Research and Engineering, so R&E, which was the precursor of the Office of the Undersecretary of Defense for R&E. So Al, you've done both the R&E role and the A&S role, including you had 2 stints as the acting Assistant Secretary of Defense for R&E. In addition, 24 years in the Air Force, culminating, you retired as a colonel. You were a weather officer, which is a really useful skill for surviving in the Pentagon. Always know how the wind is blowing. And you've got degrees in mathematics and in meteorology, which led to your career in the Air Force. So Al, welcome. I don't know of anyone who has more experience or more understanding of the S&T enterprise in the Department of Defense, and with all your various roles, starting from the basic research side all the way up to the acquisition side, and including your work most recently in the Pentagon as the A&S office was standing up. So looking forward to your insights and your perspectives on what we're doing right and what we're doing wrong.
Okay, thank you. And by the way, the one thing that being a meteorologist teaches you is how to lie with a straight face. you never know what it's going to be, so you just have to start talking.
That's good to know. Yeah, I've actually been told that there are various fields where the saying is the unifying factor is they all lie. But I've observed though that the field of meteorology has evolved from, used to be they would tell you it's either going to be sunny or it's going to rain, and now of course you get probabilities. So when you turn on the evening news, you find out there's a 30% chance of rain, so that's hedging the bet. So.
Well, if you have a large area, that means it's going to rain in 30% of the area. That's how you have to think about that.
Yeah. So Alan also mentioned you're a distinguished visiting fellow in the Emerging Technologies Institute, and you helped us kick off our very first major effort, which was an examination of something we wound up calling the modernization quandary, which was the challenge of how do we modernize the department given all the constraints that are upon us, the severe budget constraints, the fact that we have existing bills to pay, that we are lacking in flexibility in how we spend our dollars. We have process constraints in how we modernize, and of course we also have folks outside of the Pentagon who get a vote, who get a say in how the Pentagon goes forward. So first, thank you for kicking off that major effort with us. It formed the basis of our first report, which we unveiled at the ETI rollout that you joined us on. So I guess let me poke at that. In your years in the Pentagon, what have you seen as the biggest challenges to introducing new technologies into the hands of our warfighters?
I think that there are a couple of them, Mark, and it's really that's a very important question. I think the reason is that for the most part, scientists don't realize that you have to be willing to sell your product. So you just can't make something and say, it's made, they will come. You have to go out and work with the operators. You have to talk with the operators. You found that when you were chief scientist of the Air Force.
Right.
If you did things in a vacuum, nothing would happen. So you have to go out and tell people what the value of whatever you're working on will be for them. The second hardest part, in my experience in the Pentagon, is knowing when to quit something that's not working well.
Right.
So we do a very good job of starting new ideas. We do a very bad job of retiring some of those ideas. And one thing that, as you said, I went away to France for 3 years. we had one program, I'm not going to mention which name it was, but we had one program that was started. It was a pretty good idea. These things were supposed to last for about 5 years and either become self-sufficient or not. I come back in 2018 and we have more of those, none of which are self-sufficient, so the total budget continued to grow and eat at other things.
Right.
So we didn't free up money for new ideas. And you know, and you saw firsthand when you were in there, did a terrific job getting more money for hypersonics, yeah. But that was a battle.
Yeah.
And every time you want to start something new, unless there's a huge influx of money like there was in the last administration, you have to go in and take something away from someone else. So I think we have more smart people in the department who can develop good technology than we do translators who can tell the operator why something will matter. And that's really, that sounds like a silly answer, but you know, everywhere I would go when I was R&E and ANS, I would see really good ideas, but people not understanding how to sell them.
Right. No, I experienced that as well. And I you know, coming back to your point, and sometimes I would argue it's a zero-sum game. Mm-hmm. So if I'm going to plus up in hypersonics, fine, as you say. So where's the money going to come from? And that's why I was always very concerned that we not spend money in bad ways. Every dollar was precious.
Yep. And then some.
And then some, yes. And I think we both saw examples of areas where we you know, to your point on stopping things, we saw examples of things that really just didn't make a lot of sense.
Yep.
You remember my joke used to be I'd let people get away with one violation of the law of physics, but if they tried to violate 2 laws of physics, I would kick them out of the office.
I had a similar corollary, and that is if the people couldn't explain it in plain English, I would say the meeting's over. So yeah. Very much the same thing. One of the things that I'm doing now is I'm trying to help people basically around the country. And I always go back to the Heilmeyer Catechism. And the first question in the Heilmeyer Catechism is explain in plain language with no jargon what you're trying to do. The second question is, how is it done today? And the third question is, if you succeed, how will this make things better? Right. Really nice set of, a nice taxonomy way of thinking to frame up technology development.
So when we were doing the DoD S&T roadmaps, we tried to use the Heilmeyer Catechism as our construct for doing that, and having the principal directors, each one of whom was in charge of a given technology area.
Yep. We
would challenge them to answer those questions. I agree with you. Very helpful construct. And it was amazing how few people could actually articulate why they, as you say, why they wanted to do what they wanted to do.
Yep. And at the end of the day, if you don't sell yourself in the Pentagon, no one will buy what you're selling.
Right. So we spent a lot of time talking about the classic valley of death in the Pentagon. The challenge of getting out of the laboratory into the hands of the warfighter. And I think you've articulated one of the reasons we have that challenge. I would often point out, if you look at the money, it's actually not a valley of death. It's actually a mountain of death, because there is a fair amount of 6.4, 6.5, those demonstration dollars. It's just getting someone at the other end to pick up a technology that often seemed to be the challenge. Are there things that the department could be doing to make that process, to improve that process?
The jury is still out on how the Army's CFTs are going to work, but the idea of having kind of a joint board of directors with the technology person and the operator at the head of that table, just simply to get more ideas and more idea flow. I think that's really important, and you have to do that for every technical area. So, whether it's PEO Stry working with some of General Murray's folks, at Army Futures Command, it's really getting that interchange of ideas between the technologist and the operators, I think, is more important than anything else. Being able to retire things. And you mentioned the Valley of Death. and I will go back because in the Pentagon I had a saying, maybe the Valley of Death is being overrated. There is such a thing as Darwinian evolution, where some things are supposed to die.
Right.
And that comes back to you got to be able to analytically show the value of what you're doing. How is this going to make the warfighting better, or how is it going to make something cost less?
Yeah, I agree. I would even argue that if things aren't dying, then we aren't taking enough risk up front.
Right.
Things ought to die because we ought to be
pushing the envelope.
Right. Exactly. So, and if I could switch gears a little bit in terms of technology priorities. In A&S, you certainly had a list of priorities. Nuclear modernization was really high up on that list.
Yes, it is.
How do you think we're doing in that area?
So I actually have two answers for you.
Yeah.
And interestingly enough, the 10 technical areas that R&E selected for their terrific 10 in the last administration wasn't a lot different than what I had put priorities on before I left in 2015 in R&E. So we had the program where we tried to jumpstart things, and we had a couple-year program in autonomy, we had a couple-year program in quantum, we had a couple-year program in synthetic biology where we tried to focus and jumpstart things. My history in hypersonics, I think that's right.
Yeah.
So I think that we're doing pretty well in the areas. Now, the hypersonics thing is still going to be interesting because we do have to get to the point where it's a very reliable technology, and that's going to take some pretty massive failures along the way. We're going to have things not work.
Right.
But people forget every aircraft and every new airplane that you build, we have enormous number of crashes up front and failures, and that's just we are breaking new ground. So I think in that sense, the technology priorities are pretty much correct. Where I think we don't have it as correct as we should, and as I looked at the budget this year in acquisition, and then also a little bit to a certain extent in R&E, we still are centered around platforms.
Right.
And I don't think the future is centered around platforms. I think the future is centered around being able to use cyber for effects, being able to better use electronic warfare. I've been a huge proponent of electronic warfare,
right,
and we still haven't made as much progress as we should. I think some of the areas of embedded sensors for helping us do condition-based maintenance instead of schedule-based maintenance. So taking a look at how do we drive down some of the bigger cost areas in the department. Obviously, sustainment is, by some estimates, about 80% of any program.
Right.
So if I can knock out 10% of the sustainment cost, that's a lot of money that can be used for other things. So I think we have to look at the problem differently. And I came to that realization over the last couple of years, but it's a big building to move, and it's going to take time. But I would focus more on what I would call the combat enablers and less on the platforms. We have some marvelous technologies coming out, but at the end of the day, they're incremental or marginal improvement. So the Advent engine,
Yeah.
I saw a story the other day. Incredibly cool technology, but at the end of the day, it's not clear how much of a capability difference it will truly make. You get something better in there, but so that's kind of how I'm looking at it. And as I look at the overall economic landscape of the nation, it's clear that the budget is going to have pressure. Right now, we have the largest debt in history. We have the largest debt to GDP ratio in history. It's about 128%. And from the time we did the modernization quandary, I've continued to work at that. One of the real big problems is that in the early 60s, 25% of the budget was on entitlements programs, mandatory spend.
Right.
Now it's about 67%. So only about a third of the budget is truly discretionary, and half of that is defense. So therefore, if the budget has to come down, or if the nation decides that social programs are more important, that will come at the cost of defense. We do a very good job of ignoring that problem. When I was in the Pentagon, we didn't plan for the Budget Control Act, and we ended up in a very bad place with having to lay scientists and engineers off instead of planning for it. We effectively hollowed the force.
Right, right.
And that's not a place we need to be. So it's kind of, this isn't really technology, but it all plays on technology. And if the budget's smaller, we have to, I think, focus it a little bit less on some of the blue sky stuff that I really like, and a little bit more on how do we get the best capability for the kids we're going to send out into very dangerous places.
So I remember, I think, one meeting with a senior leader who actually pointed out that the Department of Defense actually is a retirement fund that occasionally purchases new equipment and every once in a while fights a war. But first and foremost, we're a retirement fund. So we're a pension fund. So yeah, I absolutely resonate with that. I also, along those lines, I think it was maybe almost 2 years ago now that when we had the first hypersonic session at Purdue, you spoke.
Yep.
And you talked about having to deliver hypersonic capabilities at scale.
Yes.
A line that I stole wholeheartedly, by the way.
I think that's terrific.
But you also pointed out that cost was an important factor, that if the weapon was too expensive, and by that I kind of extended the effects of the weapon, but if I can't buy it at scale, if I can't purchase the effects at a reasonable cost, then I'm going to be dead on arrival.
Yeah, I think that cost has to play through everything. And I would like to go back and perhaps amplify one of the comments I had. You asked what prevents us from fielding things. Yeah. I think one of the other things that the department does not do well at is converge the acquisition community and the research community as we move through prototypes.
Yeah.
So you have kind of a technology prototype which shows something will work, but then you need kind of a manufactured prototype where you think about sustainment, how you're going to manufacture it, and work on those technologies to allow you to better produce something at a lower cost.
Yeah, no, I agree. In one of our program areas, again, I won't mention which program area, but we had two contractors. One was building a demonstration version. The other was building what they called a demonstration version, but it was obvious that it could go directly, if they were successful, would go directly to a weapon. So version 1 required an extra infusion, a big infusion of cash to get it into something that was in the hands of the warfighter. Version 2 was almost ready to deliver, and so we obviously were very much more inclined to the second contractor.
I think we have to do more of that, and especially if you take a look at what President Biden wants to do with some of the large infrastructure and science bills, National Science Foundation will get a lot of money to do the blue sky research. There should be a little bit set aside for defense needs, but there's going to be, I think, a pretty healthy investment in basic sciences. I think the department, if that is the case, the department has to work really on taking those basic sciences and turning them into capability, and a little bit less basic research, a little bit more applied research.
Yeah, it'll be interesting to see if, standing up an NSF technology organization, ramping it up on that scale, and then getting them focused on defense, especially if we can get them focused on defense issues, would be a tremendous boon.
Well, it would be. NSF has not always had a great track record of being able to efficiently spend money.
Yeah, this is very true. Having as an academic of many years, and they have challenges, focusing. The peer review process that they follow is the gold standard for selecting high quality research. But it makes it very difficult to do mission area focus. It's almost the complete opposite of the DARPA model, right? Where you walk into DARPA with a great idea, you sit down with the program manager, they like it, boom, you've got a seedling. It's a very different model.
It is a different model, and there's a little bit more application space in DARPA, which I think is actually very good.
Yeah. So thinking about DARPA and how we kind of expedite acquisition.
Mm-hmm.
So we've had a variety of experiments now. I'm not sure if experiments is the right word, but a variety of different pockets within the department. Defense Innovation Unit, AFWorks, Space Development Agency,
Mm-hmm.
all of which are trying to pick away at different pieces to try to move acquisition faster.
Mm-hmm.
But some have argued that that's just kind of a band-aid solution. That are there true obstacles to implementing those sorts of improved acquisition programs across the board?
Not that. Well, I will take a step back and probably make some people fairly angry. I think that these are all good things because they're out looking for application of technology. I also contend we didn't do it that badly before. So, Office of Naval Research actually had a detachment out in Silicon Valley, and they were looking to plug things in. The Air Force Research Lab was sending active duty people out to Silicon Valley to work in Google and capture Google Maps to bring that back into Air Force mission planning systems. So I don't think that things were as bad as the common storyline goes. I do think that people actually did field things in the 70s, 80s, 90s, and zeros. I mean, we did field the first forward-looking IR from Air Force Research Laboratory in conjunction with Raytheon. So, I think you kind of have to go back to Heilmeyer and say, what's the problem you're trying to fix? And I think a lot of people have gotten enamored over the rapid turnover in technology in IT space. And I got that. But if all you're going to do is use commercial systems, then all you're going to do is guarantee that you will be equal to your adversary.
Right.
You have to have something that you put on top of it. And buying an iPhone 11 or 12 is not the same as buying a Joint Strike Fighter.
Absolutely.
So
yeah.
Now, having said that, I think rather than some of these little experiments that we're doing, SCO and DIU, DARPA's always done a very good job bringing things forward. I do believe the department does need to fundamentally change the way that they buy systems and has to embrace digital engineering.
Right.
The industry's gone that way. We tried to push that when I was in R&E a couple of years ago. Jeff Holland ran one of our communities of interest on complex adaptive systems. It was really digital engineering.
Yeah.
So we need to, in the department, not just experiment in R&Eville with DIU and SCO, but we need to fundamentally change the engineering principles of how we buy things. I think the ground-based strategic deterrent platform will be a very good, very interesting experiment, because that will be the largest, by far, digital engineered program that we will have in the department.
Right.
And I'm very hopeful. They have a terrific program manager, a PEO. I think they're going to deliver on time and for a lot less money than we would have in a traditional engineered fashion.
I was actually going to say the GBSD is to me was the poster child for the for effective use of digital engineering, and watching progress when I was in R&E, watching progress in that program, it was actually very encouraging.
Yeah.
And I agree with you. I hope that becomes the model for how we do these.
I think we have to do digital engineering in microelectronics. I think we have to do digital engineering in naval platforms and also ground-based systems. One of the nice things about digital engineering is that lends itself to open systems. And when you have open systems, you have greater competition, and you can go ahead and make modifications more quickly. So that gets you back to the rapid technology turnover you see in industry. You get to 80%, you field something, knowing in 2 years you can do a card swap out and get more capability.
Right, absolutely. As our time is coming to an end, but before we go, I did want to ask. So, is there something that the department can be doing to provide a more effective demand signal in digital engineering, or do you think we're getting it about right? Do you think industry is getting the message?
I think industry's gotten the message. I think that I think the department should, as we go through GBSD, if it works as well as I think it will, should mandate the use of digital engineering unless a program office can demonstrate why it makes sense not to use that. Just on so many aspects of sustainment, cost, being able to have upgrades, digital engineering is the only way to go. And it makes no sense to me that anybody would fight it, but
I agree with
it's
you.
just different.
I agree with you.
So I think that's really important, and we'll see how it all comes out. But so this really isn't a talk about technology as much as about how do we apply technology and new tools to buy things faster. And I think we're making progress.
Absolutely. Al Shaffer, thank you so much for joining us today. I hope I hope you'll come back in some follow-on episodes. There's so much more we can talk about.
Yeah, Mark, I would love to. And we really didn't talk about technology. We also didn't talk about some of the things in areas like synthetic biology.
Yeah.
In new forms of chemical compounds that can be used in very bad ways.
Yep. Saberni,
all the above.
Yeah.
And we have to come back and talk about how GBSD is doing now. They're post-milestone B. Yeah.
Also, at some point, you did MRAPs.
I did MRAPs.
I'd love to get your lessons learned from MRAPs as well.
But it's amazing. When Congress gives you all the money you need, you can go really fast.
Yeah, exactly.
And you have someone who's willing to waive acquisition rules. So we did concurrent engineering all over the place.
Yeah, absolutely. Al, thanks again for joining us.
Thank you.